This is Mr. Martin. These are video notes for Pre-Calculus Advanced. We are going to be looking at graphing the last two trig functions for this unit. So we're looking at graphing secant and cosecant. So when we're looking at the secant, we still have the same standard form. You can see here I have y equals d plus a secant bx minus c. So a, b, c, and d are all in the same spot. We're just swapping out one of our other trig functions that we've done already, and we're substituting in secant. And if we remember, secant is a reciprocal of cosine, so the secant of x is equal to 1 over the cosine of x. And we're going to use this fact and our unit circle to help us fill in the chart and then sketch a couple periods of the graph of f of x equals secant x. So here's our unit circle. We've got 0 here, which our coordinates are 1, 0. And then up at the top we have pi over 2, which is 0, 1. And then we have pi, which is negative 1, 0. And then down here at the bottom, which is 3 pi over 2. And 0, negative 1. Okay, keep in mind that these angles are labeled here, assuming we're rotating in a positive direction. When I rotate in a negative direction, we're going to get our negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So let's go ahead and take a look at these. Let's start at 0. So at 0, my cosine is 1. So I know that the secant is going to be the reciprocal of that, so that's still going to be 1. The reciprocal of 1 is 1. At pi over 2, my cosine is 0. So the reciprocal of 0, is undefined. So if I have 0 over 1, which is essentially what I have with the cosine at pi over 2, when I do the reciprocal, I'll have 1 over 0, and you remember from algebra, you can't divide by 0. So my secant at pi over 2 is going to be undefined. Then we move over to pi. My cosine is negative 1, so the reciprocal of that is also going to be negative 1. Then down at 3 pi over 2, my cosine is 0. Again, the reciprocal of 0 is going to be undefined. And then back at 2 pi, we have a cosine of 1. Again, the reciprocal, that would be positive 1. All right, now going back the other way, so now we're going to rotate this way. So at negative pi over 2, the cosine is 0, so the secant is going to be undefined. At pi, the cosine is negative 1, so the cosecant will also be negative 1. And then rotating around 3 pi over 2, that puts us at the same spot that pi over 2 was. Here's my cosine 0, which means that my secant will be undefined. And then again back at 0, or negative 2 pi. My cosine is 1, so my secant is also going to be 1. So I have a handful of points here to graph, and we see we have a bunch that are undefined. So when we see these values where the function is undefined, what we're going to end up with there are asymptotes. So I'm going to have an asymptote at all my pi over 2's for this. So at negative 3 pi over 2, I have an asymptote. Negative pi over 2. Positive pi over 2. And 3 pi over 2. Alright, and then let's go ahead and fill in our other points here. So I've got 2 pi, 1, negative pi, negative 1. At 0 I have positive 1. At pi I have negative 1. And then at 2 pi I also have 1. Now, for the sake of this example, we're going to be filling in some extra points that normally we won't have to fill in, but we'll do that for this example. And let's just start looking at 0 to 2 pi. So here's pi over 4, and I know the cosine at pi over 4 is root 2 over 2. So the reciprocal of that would be 2 over root 2, which would simplify to just root 2, which is about 1.4. So at pi over 4, I know I'm going to have a value of about 1.4. So let's put that there. And then pi over 3 is going to be right around here. So at pi over 3, my cosine is a half, and the reciprocal of 1/2 is 2, so I know I'm going to have a point right about here. Okay, just kind of estimating. And if I connect these with a smooth curve, I can see that this little piece is going to go like that. So notice it approaches the asymptote. All right, so that's actually 1/4 of a period of the secant curve. So looking in the next interval, here's 3 pi over 4 and 5 pi over 4, the ones on either side of pi. And again, my cosine is root 2 over 2, negative. So my secant is going to be negative root 2, which is about negative 1.4. So I'm going to have a point here and another point about here. And we're just kind of estimating these. Normally we won't even bother graphing these points when we're graphing secant and cosecant. And then again, I've got 2 pi over 3 somewhere over here and 4 pi over 3 somewhere over here. The cosines are going to be a half, negative a half. So my secants are going to be negative 2. So somewhere around here and here. And again, if I connect these, it's going to look something like this. So if you notice, this is kind of like a parabola shape, and over here this is half of a parabola shape. And then we can do the same thing over here. Over here this is our 7 pi over 4. So the cosecant is going to be root 2, which is about 1.4. And this is my 5 pi over 3. And the cosine is 1/2. So the secant is going to be 2. So we'll put those in. And then I'll connect these again with a smooth curve that approaches the asymptote. Okay, and what you can see here, this is one period of y equals secant x. One period of y equals secant x from here to here. Alright, and let's go ahead and we'll just kind of fill in the rest of the graph from 0 to negative 2 pi, and it's going to kind of be a mirror image. So I know I'm going to have a part of the curve that goes like this, and again, we're not going to take as much time as we did on the other period. We're just going to sort of fill it in. That's normally the process we'll go through. I know that this is going to look like a parabola shape that goes down this way. And then over here, I'm going to have half of a parabola that goes up and then again towards the asymptote. So this whole graph is 2 periods of y equals secant x. And again, notice the shape here of one period. I have a 1/4 period on the left, a 1/4 period on the right, and then a half a period in the middle. And these are actually going in opposite directions, unlike the smooth continuous curve that we would have for cosine x. So the last thing I'm going to draw in here is I'm going to kind of dot in the cosine curve so you can see it. So the cosine curve is going to look something like this. We'll just draw in one period over here. So you can see there's one period of my cosine curve, and the secant curve, it just kind of flips up or down. So that's what our reciprocal is looking like. So here, this has a concavity. It opens down, and this opens up. And then this part of the curve opens up, and this part of the curve opens down, and then same thing over there. So if we wanted to continue, we could just kind of dot in our cosine curve. And normally we will dot in this cosine or sine curve to help us graph this. Alright, so that is f of x equals secant of x. And you'll move on to the next video where we'll talk about f of x equals the cosecant of x, which is the reciprocal of our sine. So again, if you had any questions, make sure you write those down. Make sure you ask them. If you happen to be watching in class, you can pause the video and ask them right away. And we'll see you in the next video.